Hello, my name is Nicholas Koenig, and the article Comparison of Dimensional Accuracy Between Direct Printed Aligners and Thermoformed Aligners was written by Dr. Julie McRae, Dr. Ying-Yang Choi, Dr. Patricia Snyder, Dr. Andrew Hayes, Dr. Ki-Byung Kim, and myself, with research done in St. Louis University.
Traditionally, aligners are manufactured in a four-step process. Step 1 is the impression. Step 2 is the treatment planning. Step 3 is printing the 3D models. And Step 4 is thermoformation of the aligners on the 3D models. Now, with novel technology, it is possible to directly print aligners and eliminate one of the steps in the process, specifically the thermoformation process. A previous study assessing the dimensional accuracy of aligners found aligner gaps between the aligner and the master model ranging between 0.102 to 0.351 millimeters. Another study found gaps ranging between 0.047 to 0.651 millimeters. In order to compare the dimensional accuracy of traditionally thermoformed aligners and direct printed aligners, a master STL file of a maxillary arch with moderate crowding was used to print 24 resin models with a DLP printer. Sendura FLX aligner material was used to thermoform 12 aligners over 12 of these resin models, and Essex ACE aligner material was used to thermoform 12 other aligners over the other 12 remaining resin models. Next, using the same DLP printer and the same master STL file, 12 direct printed aligners were made using photopolymerizable polyurethane resin. Next, the intaglio of the aligners was sprayed with a CAD/CAM spray and scanned with a 3D scanner. The scans were superimposed on the master STL file using the best fit alignment function of an engineering software. Discrepancies between the scan mesh and the master STL were measured at different points for each of the 36 aligners. The points consisted of 9 bilateral landmarks located on the teeth along the arch. Each point in this graph represents the discrepancy at one of the landmarks previously described. Every color in this graph represents one of the 12 Essex aligners. We can appreciate the wide variation and magnitude of discrepancies in every one of the aligners. The values of absolute mean discrepancies ranged between 0.188 millimeters and 0.457 millimeters in the Essex ACE sample. In this graph, we can observe the discrepancies between the master STL and the 12 Sendura aligners. We can appreciate that the variation in magnitude was not as great as the ones for the Essex aligners. The discrepancies ranged between 0.76 millimeters and 0.26 millimeters. In this graph, we can observe the discrepancies between the direct printed aligners and the master STL file. We can appreciate that the magnitude and variation of the discrepancies was less than in the thermoformed aligners. In 6 of the 9 bilateral landmarks, significant differences were found between the direct print aligners and the thermoformed aligners. Therefore, we can conclude that the direct printed aligners had a better dimensional accuracy than the thermoformed aligners in the sample. Reasons for why direct printed aligners were more accurate could be because they avoided two error-prone steps. Specifically, they avoided the printing of the resin 3D models, which is associated with error, and they also avoided the thermoformation, which also is associated with error. It was interesting to note that more posterior landmarks on thermoformed aligners had greater magnitudes of discrepancy. This could be because thermoformed aligners were disengaged distal to the second molar area. Some required substantial force that could have induced permanent deformations in these areas. Possible limitations to this study included the CAD/CAM scanning spray that added a thickness to the aligners. Also, different scanners were used.
In conclusion, the sample in this study demonstrated that direct printed aligners had better dimensional accuracy than thermoformed aligners. However, this study might have been underpowered because the sample size calculation was invalidated. Also, scanning inaccuracies and sample preparation could have added error to the measurements. Finally, this was an in vitro study. Therefore, the results should be interpreted with caution, and no clinical decisions should be made based on the results of this study. You can find this article in the June 2022 issue of the Korean Journal of Orthodontics. Thank you.